Hi, my name is Teacher Maxime, and today I'll be recording a video to prove that for small angles, sine theta normally tends towards theta if the angle is expressed in radians, and tan theta also tends towards theta, and cos theta tends towards 1 minus a half theta squared. From the start of this video to the end, I'd like you to practice alongside with me, so that at least you can be able to understand how this law works very well. To start you off, I'm going to draw a sector. This sector looks like that. This is R units. I'm going to draw a perpendicular line from that point to this point. They're going to meet at 90 degrees. Our angle here is theta. This distance, let's talk about O. This is A and then B. The distance OB is less than radius, so I'll just call it adjacent. And the distance AB is our opposite, and our distance AO is our radius, which you can call it the hypotenuse. From the laws of trigonometry, sine theta is normally given as opposite over hypotenuse, and our opposite in this case is AB. So we're going to have AB divided by our hypotenuse, which is R. But as theta turns towards the zero, meaning that if we make the angle to be smaller and smaller, to be very small, there's something that's unusual that is happening in this case. As the angle becomes smaller, our opposite also becomes very small. So it means that as it goes towards zero, this opposite of ours is going to tend towards the circumference. So our AB, which is opposite, is going to be the arc length, which is normally given by r theta when theta is in radians. So to mean that the sine theta is going to be our distance AB when theta is 0 is going to be r theta divided by r. So if you cancel the r's off, you're going to have the angle theta. Let's prove tan theta then. I'm going to redraw the diagram. There we have the diagram. This is our distance here. This is our R. Then this is our A. This is our B. Then this is our, let's say, C. Now, let's see what happens in this case. This is our theta. Our tan theta is opposite, which is AB, divided by adjacent, which is a CB, or we can say BC. It's up to you. Now, one thing you need to know, as the value of theta tends towards 0, AB tends towards the arc length, which is given by r theta. Now, let's see. Again, as the value of theta tends towards 0, the distance CB tends towards the radius. So, if this angle is 0 degrees, our distance CA and our distance CB, they'll be equal. So, to mean that our tan theta will be equivalent to our AB when theta is 0, which is going to be the arc length r theta divided by BC when theta is 0, which will be equivalent to our radius. When you cancel them off, you're going to have tan theta tending towards theta. For cosine theta, proving it this way, it's not going to come out clearly. But we know that for double angle, when you have cos, 2 theta is given us 1 minus 2 sine squared theta. To mean that if you are looking for cos theta, it means that we are halving the argument. So if you're halving the argument, we are going to have 2 sine square of this must also be halved. I'm going to have a half theta. And so we're going to have 1 minus 2 into bracket sine a half theta squared. But we say that as theta becomes smaller, as theta tends towards 0, sine theta tends towards theta. Sin theta equals to 0. Equals theta, not 0. So this follows that cos theta will be 1 minus sine a half theta will turn to a half theta. Then this is squared. But remember we have a 2 before, so meaning that you're going to have 1 minus 2 times the square of a half is a quarter theta squared. And the answer is going to be 1 minus a half theta squared. You have learned that for smaller angles, sine theta equals to theta, cos theta equals to 1 minus a half theta squared, and tan theta equals to theta. This one happens when theta is in radians and theta tends towards 0. Thank you very much for your participation in watching this video, and I wish you a wonderful day ahead.